All right, we're starting with number 11. We finished with 10. We're going to start with 11 here. Now, use the figure to find the measure of angle 1. This is not a triangle. There's a little bend here, so this is actually a quadrilateral. These are two separate sides. It bends. The reason I know that is because that's 190 degrees, not 180 degrees. So, if that's 190 degrees all the way there, these two sides are congruent, so that's going to make this angle 40 degrees. That's going to make 40 and 40 make 80 when I add these together. So I want to figure out what this part of the rectangle is, a triangle is, sorry. So I'm going to take 180 degrees minus the 80 degrees that are already here, and that's 100 degrees. So this part of the 190 degrees is, well, let me just point that there, is 100 degrees. Well, what's left out of 190 if we take 100 away? What's left here is 90 degrees. So that's, this part of the angle is 100, this part is 90. Now we need to find the measure of angle 1. I see this side and this side are marked congruent. If this is 90 and these two sides are the same, that means we have 180 minus 90 is 90 degrees left for these two angles, which are the same. So 90 divided by 2 is 45 degrees. And that's what the measure of angle 1 is, 45 degrees. Number 12, find x. All right, this shouldn't be too bad because I see three sides. Now I could add them all together, 15x plus 18x minus 12 plus 10x plus 20 equals 180. But an equilateral triangle is also equiangular, which means each one of these angles is 60 degrees, here, here, and here. So I'm going to just solve the real quick. 15x equals 60. I'll divide that by 15. So x is 4. I think that's the answer. I'm going to check real quick. 15 times 4 is 60. 18 times 4 is 72. 72 minus 12 is 60. 10 times 4 is 40. 40 plus 20 is 60. All right, so that does work. All right, so that's 1 through 12. You should have done these problems first. Check yours against mine. If one of us, if we're different, let's find out why tomorrow. We'll ask that question. Now, I do have a proof here. And in this quadrilateral, ABCD, AB and CD are parallel. And I marked it with the arrows. But they're also congruent. And I marked that with the slash. What we are to prove is that angle A, this angle right here, is congruent to angle C. And the way we're going to do it is by showing that these two triangles are congruent first, and then use the CPCTC. Corresponding parts of congruent triangles are congruent. All right, so let's make some statements. And I might try this by not just listing both givens first. I might try to build off of each one. Let's build with the parallel. Segment AB is parallel to segment CD. All right, now if they're parallel, where's that going to help us? Well, what I see here is parallel sides. I see a transversal, which means this angle and this angle are congruent. Let me put two loops in this. Those two angles are congruent, which is angle A, B, D, and angle C, A, B, D, whoops, angle C, D, B. Those two are congruent, and the reason they're congruent is because, oh, let me write this. If Two parallel lines are cut by a transversal. That's my lazy way of writing that, all that condition, that hypothesis. Then alternate interior angles are congruent. All right, so I've got these two angles. Now the next thing I have, I'm going to put the next given in, but segment AB is congruent to segment CD. Alrighty, so I've got side here, angle here, side here, angle here, side angle. I got to prove these, so I can't use that angle. I got nothing here on what those angles might be, but what I do have is BD is congruent to itself, and it's in both triangles. That's why we're writing that down. And a lot of you remember when to put in the reflexive property. And that's what we got. A segment's congruent to itself. So side angle side looks like it's going to be able to get us these triangles congruent. So I'm going to go triangle A, B, D is congruent to triangle C, D, B because of side angle side. And you only have to write SAS for that. Now, what I have is angle A and angle C correspond to each other, and they're incongruent triangles. So, corresponding parts of congruent triangles are congruent. So you need to just be able to put something together like that on the weighted version of the test. All right, look forward to seeing you tomorrow. Bye for now.